Hello, this is simply about networking protocols, and today I'll tell you about EVPN plus VxLAN. Standards required to understand VPN in general, EVPN, and basics of EVPN are presented on the screen. There are much more possibilities, features, use cases for EVPN. They are covered by separate standards. You will start here and then go to the necessary standard depending on your situation and configuration. In this video, I will tell briefly why do we need EVPN, some EVPN terminology. There is more you will see in standards. EVPN operations about sharing routes, EVPN operations about learning routes, and EVPN general operation flow, very schematic. There is more use cases, more complex configurations, more different modes of the operation of the EVPN and devices that included into VPN. So it will be too much to talk about this in single video. Brief description. Why do we need a VPN? Imagine you have many devices that needs to be working in the way that they are connected to the same switch or router, but they are split physically, not just in like separate rooms, but in separate buildings, in separate cities, in separate I don't know, countries, continents, whatever. We know what to do in this case. In case we need to connect two ends of the same subnet, we should create a tunnel. Well, as you remember from previous videos about tunnels, all tunnels that we overviewed in videos are single direction, so we need basically two tunnels to send traffic back and forth. But what if we have situation when multiple different locations are required to operate in the way that all devices are connected to the same switch or router? Yes, of course, we can create necessary tunnels, but what if device from here, from the left, needs to send some part of traffic to the device on top, some part of traffic to the device on the bottom, and some part of traffic to the device on the right? Again, as you remember from videos of tunnels overview, most tunnels has single mapping. So all traffic from one device can get to the same tunnel. There is no ifs that allow us to route traffic to different tunnels. Well, in some cases it's possible, but in general, this is possible. You all heard about VPN that allows to build a subnet that are locally that are locationally divided, but working as they connected to the same router, based on IP. But what if we need L2 traffic, Ethernet traffic? There is IP layer can be available, cannot be available. So everything that we can depend on is MAC and VLAN. So in this case appears EVPN, Ethernet VPN, for L2 traffic based on MACs and VLANs, MAC addresses and VLAN IDs. Some terminology. Provider edge. Provider edge is the router that we need to configure a VPN on in order to start working as a EVPN. So this is boundary router that enables entry into a VPN network. Customer edge device. This is device that is connected to our provider edge. Only those devices that are directly connected to our provider edge by a link. Broadcast domain is all devices that are connected to our provider edge in some way and needs to operate as they are in the same domain, that they are connected to the same switch, basically, because we're talking about Mac and Will, Ethernet 2. In my visual example, we have 3 different broadcast domains, blue, green, and purple, I believe. So EVPN, this is set of configurations, features, and protocols that allow us to, in specific way, determine the destination of the traffic and to select proper destination, proper tunnel to be used, or proper session to be used, proper label to be used for the traffic that will go to specific defined destination. In different sources, you can see different highlights of the VPN. It can be by the provider edge, it can be by the edge of the provider edge, but anyways, customer edge not included into EVPN because customer edge doesn't need configurations related to EVPN. It's just working as a normal device. EVPN configuration started at provider edge. And again, as you already saw in set of specifications, BGP is mentioned. It can be mentioned in two ways: MP multi-protocol BGP or iBGP. iBGP, internal BGP. This is the set of the BGP protocols that is required to exchange routes between BGP devices within the same autonomous system. But this BGP is related to EVPN. Your provider edge devices could be part of the BGP structure of your autonomous system, but in order to operate with EVPN, they should not or must not, or in other words, this BGP is BGP for EVPN strictly. This BGP is configured in the way to operate within specific EVPN configuration, share routes only within this specific EVPN configuration, and does not cooperate with BGP infrastructure of your autonomous system where you are. And basically, BGP is used to build BGP backbone of provider edge devices in order to connect them and allow them to exchange EVPN routes. Sharing routes. We have our provider edge. Every provider edge on scheme will do the same. So you can add provider edges here in your imagination, and they will do the same operations as this one. We have our broadcast domains, and yes, those broadcast domains by customer edge devices connected to our provider edge, they have some MAC addresses. All other devices within those broadcast domains also have MAC addresses that we will use to distinguish those devices among them. And now appears EVPN instance. This is so in basic, most simple configuration and in use case, EVPN instance equals to one single domain. In more complicated use cases, complicated configurations, it can be not that, but you can read about that in specifications. For now, you can imagine that instance is a domain. And it means that instance should have ID, same on all provider edges that includes this broadcast domain. So on each provider edge for this particular VLAN 3, a VPN instance should have ID 1. In reality, ID is more complicated. You can read how provider edge route distinguisher, how a VPN instance ID are assigned in specifications. I won't stop here on that. So we are learning MAC addresses of all devices of our broadcast domains per EVPN instances, and I mean all devices that will participate in EVPN infrastructure and will share traffic, exchange traffic with other devices on different provider edges. Those traffic are transferred to BGP. Again, BGP for EVPN, I wrote it in this way to highlight this is BGP for EVPN, for this EVPN structure that we are building here. It builds kind of routes highlighting which instances, MAC addresses, VLANs it has, and sends to other BGP instances on other provider edges. So you can ask, where is VxLAN? Ta-da! Here it is. VxLAN is only a part of transport system for traffic to be exchanged between provider edges. Again, as you could see in specification already, the most focus is on MPLS because those specifications are written in scope of data centers. But in specifications also highlighted that any transportation or tunneling methodology can be used. VxLAN, IP, GRV, MPLS, whatever you're using in your company, what is historical legacy of your company, and so on and so forth. It doesn't matter. Okay, we have sent our routes to other provider edges. Other provider edges perform the same operation and sending their routes to us. Those routes are getting to BGP for EVPN with information from which device, from which provider edge we received it. Technically, it should be written router distinguisher, but again, router distinguisher, pretty complex thing to add into this video. Just remember, BGP distinguished from which device, which route was received. This information is transmitted to EVPN by BGP, because BGP is used only for routes operations and management. And now EVPN operations, how this information is used. Imagine we need to send some packet to some specific device on behind different provider edge. This packet will have MAC address, this packet will have some VLAN. It will be from broadcast domain, so it depends to specific Ethernet VPN instance. So before selecting a tunnel to send this packet, we are asking EVPN about necessary information. EVPN provides necessary information into tunnel selection procedure. Tunnel is being selected, packet is being wrapped into necessary additional Ethernet fields and IP fields for VxLAN and sent specifically to provider edge where our destination device belongs. This is already VxLAN. So there, this packet will be processed on the destination. This packet will be processed by VxLAN termination point. That how it's simple in its basics. For more details, read specification. Thank you, have a great day.